Greetings, fellow nerds. Welcome to another episode of Between Two Nerds, where we talk with prominent guests about all aspects of the networking industry, from protocols old and new to industry trends and drivers to up-and-coming technologies, and as always, things you should know to further your career. And we've got a amazing group of guests here. Jeff, I think I'm going to leave it to you because you work closely with everyone here, and I'm betting most of the audience knows all of our guests today. But I'm going to leave it to you to introduce everybody.
Hey Jeff, thanks everyone. It's really amazing to see everyone here. We are long time friends, acquaintances. We all work at the same companies at some point in life. But we all know from this perspective. And what you also see is not only people who are working on BGP over QUIC, but a group of people who are fundamental to some work done in ATF, people who have been developing some standards for as many as 20 years. And again, it's amazing to see everybody together here. So I would say virtually family.
Yeah. So Jeff Haas has been a previous guest on here. We had our Three Jeffs show. To be honest, I don't even remember what the topic was then. But
BGP Futures, which overlaps the discussion here.
Yeah, absolutely. It was a nice anticipation of this show, I guess. That was maybe a year and a half ago, something like that.
About, yeah.
Yingjin, would you introduce yourself?
Hi, I'm Yingjin. First time on the show. Happy to be here. So I have been working in the networking industry for some years. Yeah, mainly focusing in the routing area, routing protocols specifically.
Fantastic, and thank you for joining us. And Alvaro, I think, I might be mistaken, but I think this is the first time you and I have ever spoken. I have known your name across the industry for decades, and really pleased to have you on here.
Thanks, Jeff. Yes, I think we've probably exchanged messages here and there, but I think face to face, it is probably the first time.
Yeah,
I am, of course, like everyone else, familiar with your work. I'm kind of sad today that my name is not Jeff, but there are worse things in the world that can happen. Very happy to be here.
Yeah, so I actually want to show the book on the show. So this is how I get started in the networking industry, and now I'm meeting the real Jeff on the show, and we'll be happy to meet you next week in Nanauk.
Oh, wonderful. I'm glad you're going to be there.
Yes, I'll be there.
So our topic for today, as everybody that joined us, I'm sure has seen, is BGP over QUIC. Jeff and I did a show, Jeff T and I did a show previously, the last show, as an overview of QUIC, the particular advantages and why QUIC is expected to be an improvement over TCP, that we did that specifically as a lead-in to this show. And in our pre-show conversations, we were actually talking about, where some of the advantages of QUIC might not be all that relevant to BGP. Things like, better multiplex. Well, multiplexing might be a better use of it, but things like persistence through network changes or address mappings, from behind NAT, things like that. Dealing with congestion problems and all that may or may not actually apply to BGP, but there are some specific characteristics of QUIC that do apply to BGP, and I think the most prominent everybody correct me if I'm wrong. Oh, I should actually say, I'm the only one on here that is not an author of the Internet Draft on BGP over QUIC. So I'm sort of learning from everybody here in this show, along with the audience. But what I think, what sort of stands out to me about QUIC as a useful characteristic for BGP is the fact that you have multiple streams, and you can have either bidirectional streams or you can have unidirectional streams. And with this specification, BGP establishes, first of all, a control session. And all your open messages, notifications, keep alives, I believe, go over this control session. And then you have separate functional sessions in which NLRI is actually exchanged. And those can be either unidirectional or bidirectional. Am I stating that accurately?
You are, I think, in general. If I want to take maybe a step back of why I started thinking about QUIC, is QUIC has had a relatively fast rise in networking, and I think most of us here are all mostly routing protocol people. Yeah. And we look at transport protocols, and sure, they get us from here to there, and TCP has been valuable. But one thing that I think in the ATF especially we keep hearing from people is not just about BGP, but in general about lack of security. Yeah. And of course, QUIC is one of those things, is one of those protocols that are going to give us confidentiality and authentication and mechanisms that are not necessarily built into TCP. Even though, for example, TCP/AO is available, or even before MD5, not everyone used that. Not everyone, or almost no one that I know, uses encryption with TCP, even though that is available as well. Where sort of QUIC, the low-hanging fruit to me was that, right? When I heard about QUIC many, many years ago, is okay, now we have a transport protocol that could give us those things. It turns out that you're right. All these other things that QUIC has, besides just changing transports and making it secure and satisfying security concerns, instead of just running around naked in your network, sending updates everywhere, is what gives us the value. So what you describe about the streams, I think is correct. Yes, we're trying to use the streams to separate address families. It's going to give us more resiliency, better availability. It lets us handle addresses independently. If there's an error in one, we don't need to reset the session. We can just keep going with the other one. We can spin up new address families whenever we want, not just at the beginning of a session. Things along those lines that maybe were planned, or maybe people thought about but never crystallized. Dynamic capabilities, for example, and things along those lines.
I think also approach is different, right? In BGP security, or in TCP, not in BGP, security came as afterthought. And even though TCP has been around for quite some time, we've seen first implementation as late as last year, and it's still probably 1-2 vendors that have implemented it. So it's similar to IPv6 story. Everyone has been talking about how MD5 is insecure, but guess what? 90% of BGP sessions in the world are still secured by MD5. Even though TCP/IO is available in Junos and potentially some others, right? It's in implementations. So rather than putting something on top of it that people are really reluctant to implement because that kind of works, we are getting into a place where security is built in. It's fundamental to operations of QUIC, which creates additional complexity to actually implement it. But practically, if you have security. It's not optional anymore.
So you're speaking specifically of TLS, which is just a foundational part of QUIC, right?
Yeah.
And one of the things TLS gives us that's An interesting bit of plumbing to think about is you get certificates with it. You can certainly do shared keys and such, make it look like existing security mechanisms. But picture a data center where you want some level of security, but you don't want the headaches of pre-provisioning everything. Well, you can run something like Acme to hand out security certificates to tie into things. So one of the challenges we're going to run into for BGP deployment over QUIC is what does the security model support? Where do we get good benefits for it as an interesting add-on for places where we want it? For places where it gets in the way, or people might be scared. Certificates scare people. What happens if the certificate expires that's carrying all of your internet traffic? Well, this could be a bad thing. So we want to actually work through those things and find out where it's good and where it's bad.
Yeah, so the certificates that put a lot of headache for routing systems, right? Because today's router, we don't have a RPKI sort of infrastructure. But if you step back a little bit, TLS does support pre-shared keys as our bottom line for security. Yeah.
Still be down to kind of MD5 static pre-shared keys.
But the authentic the password, at least compare with MD5, is more complicated, harder to conquer, right?
Mm-hmm.
MD5, I think isn't it already deprecated?
Very long time.
Yeah. So
at least people are using it. So
you can use SHA-250. What's that? 256 or something, or 512 more secure password compared with MD5.
Yeah,
so kind of an ignorant question on my part, as in a practical BGP over QUIC deployment, if you are just assuming, well, everything is secure because it's running over TLS, would I still be running SHA 256 or MD5 or whatever on top of that?
I think if you take the usual mix of things, this PIC IPsec is a good way to talk about this. We're looking at integrity is the property BGP really needed out of MD5 and AO. We want to make sure that people can't do man in the middle, that people can't do remote session resets.
Right.
And one of the things that I think will be an interesting bit of security analysis is what sort of remote attacks you can do that are disruptive to QUIC sessions from remote. The TLS gives you an awful lot of what you need, but at the IP layer, QUIC isn't helping you there. That's a place where TCP MD5 and AO, they go deeper into the layer 4 type stuff.
Mm-hmm.
So there's probably a little bit of attack surface left that will make some of the transport people interested. And we will have to at least talk about this over the life cycle of this document, because unlike standard TLS, where you're just simply, in a lot of cases, you're doing it transaction based. You spin something up, talk to it, it lasts for a while. BGP sessions have been known to last for years.
Yeah.
So one interesting question this is going to be, how resilient is it to attack over that long of a life cycle? And fundamentally, it's going to come down to bugs. I've been in prior employers where TLS daemons were used as a tunneling protocol, and the sessions would stay up for weeks, and then all of a sudden we'd glitch out on some error inside the library. TCP got an awful lot of hardening work as a side effect of things like BGP running on top of it, and QUIC is probably going to get the same sort of work out over its life cycle from BGP.
No, the one thing that we don't know, but we hope it's going to work, and everyone I think we've talked to in QUIC also thinks it's going to work, is what you're talking about, Jeff, of the length of the sessions. A lot of QUIC was optimized for HTTP3, right? So you come up, you exchange stuff, you go down, and that's it. A few seconds, maybe that's it. There's some work now on doing media over QUIC. So I'm assuming, okay, that's going to be longer, but it might be minutes. I don't know if hours. But again, that's nothing compared to weeks, months, years.
Yeah.
Mm-hmm.
And so we hope, and as I said, everyone that we've sort of bounced this idea by who works on QUIC, believes this won't be an issue. Yeah, we'll have to see. I mean, there's a couple of things that we've been sort of uncovering. As you said before, we're using streams, and so we can bring up new address families we're taking down. One of the things is that we cannot reuse the same streams. So if you decide today that you're doing IPv6 and tomorrow you're not, and then you're again, and you go up and down different address families, there's a chance that at some point you're going to run out of stream numbers. Of course, that point is long, right? It's a very far away point. But there are cases like that where the infrastructure of QUIC was probably not thought of for those long-lived sessions, because the limits, haven't been proved. No matter how many streams you're doing for HTTP3, you're probably never going to run out of them because of the length of the sessions.
And you can recycle eventually the IDs, right?
Right. So we're, at some point, testing the limits and being pioneers in control protocols, running over this new transport.
Yeah, the number of the stream ID is large enough right now. We look at it, but technically it can run out. When that happens, the QUIC session need to reset, so you can start from 0 again.
Yeah, it's a very, very big number. So I'm
yes,
not expecting
I think it's
to the 62nd, I think.
Yeah, 60 seconds. Yeah.
Yeah, it shouldn't be an issue. Of course, famous.
Technically, that can happen.
Yeah.
Far more likely, we're going to run into bugs in the implementations dealing with stream numbers over and their recycling.
Yeah.
So,
yeah. The problem is that stream ID is when you open a stream, you set your stream ID. Let's say you start from 2 power 61, then you are doomed. That number can only keep increasing. You can now use a number lower than that. Yeah.
Yeah, and I was, I was thinking with a number like that, it seems like, any sanely running, BGP network, you should never deplete that number of streams. But could it have implications if your BGP session is flapping? Are you going to increment?
Even you are flapping, right? If you just go up one by one, you still have a lot of spaces. But the problem, if you have a bug in your software, you jump too fast.
Or you start close to the end.
Yeah, you move to your end very quick.
Yeah.
If you have a bug in your software, that can happen theoretically.
So let's maybe try to go back to problem statement. And what is it we specifically dislike? I mean, dislike is not the right word. What could be improved in current implementation? So I would start with error handling, fade sharing, and ability to bring new functionality on top of existing sessions.
Yeah, and you're mentioning what happens when the session flaps. What does that actually mean when we're talking about BGP over QUIC? Because it's not really the same thing anymore. we're changing the rules. The control channels primarily there just to get the session up between the boxes and exchange critical things, and more importantly, small correction from the start of the show. We're for the function channels, we're looking at having them be unidirectional rather than bidirectional.
Oh, okay.
And that's going to have some interesting implications on how BGP runs the state machine. We're spending a lot of our head scratching right now working on that as our big topic at the moment, because it still resembles strongly BGP in many respects, but there's little quirks, and that means that some of the states are going to get squished together. They're probably going to get different names, and this is not the sexy thing they talk about in this show, but it's definitely where the interesting piece of work is. But anybody who's worked on BGP before is going to have a semblance of how this stuff behaves. And where it gets all sort of interesting is that since the function channels are unidirectional, and the motivation for that, because we went back and forth on our own about should this be bidirectional. Well, one of the answers is if it's bidirectional and you have a headache on one side, let's say your layer 3 VPNs are coming out and all of a sudden have an error. Well, why do you want to take down the stream that has the other guy's stuff when he didn't do anything wrong? So we're separating it. It's no longer fate shared as if it's running on a single connection like traditional BGP is. But as a side effect, that means that some of the communication for bootstrapping the state machinery has to be passed along through the control channel. So we basically get a open ACK that passes on the control channel rather than a bidirectional open in the other direction. And you start getting small details like route refresh, notifications, that sort of thing of what stuff goes in the control channel, what stuff goes in the function channels. That's where all the subtleties are. But sort of end of the day, what we're trying to get to about that flapping case is, if the transport's still able to stay up between two systems and you have a issue in one of your address families, maybe you can just simply reset that address family and keep going, because sometimes it's just a bug in your PDU generation. If it's a bug in the device as a whole, well, it's no different than traditional BGP. You have to knock the entire thing over and start from scratch.
Yeah, and if the flap is more physical layer, you've got a bad NIC or something like that, I mean, the control session and everything is going to go down. And when something like that happens, when you go all the way to reestablishing, so you establish a new QUIC connection, and then BGP establishes a control session. Does the numbering for all of the other sessions start? And by the control session, correct me if I'm wrong, the control session is always session ID 0, right?
Right.
Yes.
And so you start numbering up from there. But does the numbering start all over? So the whole thing, I was kind of saying, well, you got flapping.
Yeah, because it's a new QUIC session.
Yeah. So that sort of.
Well, that's where we get into, again, some more of the fun. If it's just the sessions got knocked over because your NIC had an issue for a second.
Yeah.
If it's TCP, you hang up and try again.
Mm-hmm.
If it's QUIC lets you do session resumption. So one of the interesting things is if your BGP timers are happy with this thing, and for how you're deploying BGP, it's like Jeff gave an excellent example a little bit earlier about data center stuff. Sometimes you want that to get knocked over right away, and you want it to stay down. But if you're doing traditional internet service provider, it takes you forever to exchange your tables, mostly not because of the slow transport. We're not actually leveraging QUIC to be fast. BGP isn't a lot of data traffic. It's less than a lot of web pages. It's mostly, here's a bunch of PDUs, here's a lot of CPU that goes behind that. So if you could avoid having to resend your entire tables for circumstances where you can hold your breath for a few seconds and just let at the transport layer the reconnection happen, you've saved yourself a lot of protocol grief.
And I think it's important to take a look at evolution of BGP. Like 4071, something goes wrong, notification, restart. Revise error handling, which many people here worked upon, allows us to treat some of this as withdrawals. So rather than restarting the session, we will just silently drop. However, it's kind of partial solution, right? Because it cannot solve all the issues, and in many cases, you will still go through BGP reset. So going towards what has been discussed for QUIC, it's really the evolutionary step towards complete non-fade sharing between different office and ability. It increases survivability of BGP as such. And we are running more and more stuff about BGP, right? We know the track history. We put more and more stuff.
Everything over BGP. Yes.
Yeah, and it all interacts with each other, right? Eventually, if you don't have proper protection, you share fate, and someone on the internet decided to do something. On top of that, in worst case, it's going to be transitive, and someone else is going to receive it and say, and to restart. So by using something completely decoupled different streams, you will go and restart this one thing, but your IPv4, IPv6 is still working. People can still, use Facebook and YouTube.
Yeah. I'm curious. You were talking about the individual function streams. And maybe I should ask this. I'm not sure. I think I read it in the draft, but I can't remember. Can you have just one function stream, even though you have multiple address families, or do you have to have separate streams for each address family?
The motivation's for us to have a separate function channel per AFI-SAFI set.
Yeah.
And we spent a little bit of time talking about, does it ever make sense to have, we're going to certainly, we want that decoupling for the address families because it lets us spin them up dynamically. There's a feature that was not well deployed called BGP multi-session. We're getting a lot of the benefits that were proposed for that. They can go up and down independently, so we get the resiliency benefits of not having to take down the entire session between two boxes just because of an error on one address family. And we talked about, well, what if you wanted to do things like prioritization as an example? Because the whole problem is when you look at BGP, traditional BGPs, one giant fire hose that you're trying to shove everything down there. So if you got your internet that's roughly 950K routes these days, and your IPv6 internet that's roughly 200K routes, and you have some layer 3 VPNs and some MPLS, and and we keep on piling more things into it to the unhappiness of some of the internet service providers. They're happy with the features as long as it's their feature. But the problem is once you have too much work to do, the only thing you can do is prioritize. And the BGP RFC doesn't talk about the do about that. You just have a giant fire hose, and it's up to every implementation to do what they want to. And some implementations actually give you, some knobs to be able to shove things around. Like Junos actually has, a user configurable prioritization mechanism, which can be helpful in some circumstances. But once we start changing the rules, well, it's the same sort of thing. If it's one AFI-SAFI, it's still a fire hose per address family, just smaller. So if you have prioritization going on, and you have the ability to do more than one stream, you get benefit out of trying to do maybe, say, 2 IPv4 unicast. Channel number 1 might actually be set up, for you to get just your IGP loopbacks, and channel number 2 might be all the rest of your internet. And maybe you get nice benefits for that. But the trouble is you also start getting a lot of very weird protocol ambiguities. If you get a notification for an address family, are you taking down 1/2 of your IPv4 unicast? If you're doing a route refresh for IPv4 unicast, does it get addressed to one or both of them? So there's options. Our talk at this point is that even though the prioritization might be sort of cool, there's enough ambiguities that we're sticking to the simple thing for right now, and we still have the ability to do prioritization at the sending side of things rather than trying to split it across the transport.
And the issue is getting more and more severe, right? Because amount of state is increasing. Others, data center, hyperscale network, or internet, number of routes is growing no matter what, because disaggregation is happening. Another point here is that at least in hyperscaler space, people are trying to make BGP more intelligent, right? So for example, you might get your net flow and figure out who you want to do add paths for. Practically, you end up with tens of millions of routes, even for internet, just because of add paths. So practically, you would like to prefer one set of routes from another. Using TCP is the only way to do it is use separate TCP sessions, pretty much, right? Very ugly way deployed today, but there's a lot of space for improvement, and I think this is why this work is so exciting. It's really not only new transport, but all the improvements. Because the most important goal of all the BGP developments have been backwards compatibility, always. So you have to carry all this legacy, even though a lot of it's 20 plus years old. Some of it doesn't make sense. Some of it is actually harmful, but just because of kind of fundamental role of BGP for internet, we cannot really change it. We get an opportunity to make things better.
Even though we are completely changing how the sessions work.
Yeah.
So yeah, we can't change it, but we're changing everything. And I want to stress the point that Jeff made, which is, yes, we're starting with simple things in terms of like flow control, handling it in a simple way. But at the same time, we made that conscious decision that he talked about of going all the way in. So we could have just said, take away TCP, put QUIC, and that's it, right? Forget all the streams, just set up a connection, and you have the same one host, one connection session with your peers, and you get all the routes in the same way. It's just the transport is different. But we decided that even though that could give us some benefits, if we're going to go do this, we should do it right. And what we feel right is taking advantage of all the things that the transport is going to give us to make BGP that much better. That much, I would say, but that's much different, but that's much better, at least for this one session. And as this keeps going everywhere, hopefully that benefit, we're going to see it end to end across the internet at some point. But yes, that's the conscious decision. And yes, we discussed, we had different opinions, we played with all kinds of corner cases and things. But it is a decision that makes sense. If we're going to do something, we need to take advantage of everything that we can, so that it provides the maximum benefit.
Yeah, we had long discussions about how to make better use of those streams. And so in the end, at least until right now, we settled like we will have one control channel and one function channel for one RF-SAFI. Yeah, but QUIC stream has the capability, to provide per stream flow control. So you can still have sort of priority management among different streams.
Which is fundamental kind of service provider world when you have 2,000-3,000 infrastructure routes, but potentially couple of millions VPN routes, right? So a very different amount of data to exchange and potentially different characteristics and priorities.
But even for the QUIC RFC itself, it doesn't specify how these priorities should work, right? It's really up to your implementation, and it's a case by case, right? You cannot just say, oh, my IPv4 route is always important, the most important thing. That's not true for everybody. So it really depends on your network.
Yeah, one of the things that gets sort of interesting for the prioritization, with TCP, the sender controls everything. The receiver just eats it as fast as they like. With QUIC, the sender gets a chance on each stream to push as hard as they want to, but they can only push as hard as the receiver on each of the receiving streams gives tokens back.
Right.
So the interesting thing that's going to be a change in the equation that we have is like sender prioritization is no longer quite enough. You also have to balance out receiver prioritization. So that's going to be an interesting set of conversations.
Sort of going maybe to the other extreme, I asked the question, is it possible to shove everything, all of your address families, onto one session? Which I don't know why anybody would want to do that, but sort of going to the other extreme, beyond just AFI and SAFI sets. Is there the potential for being more granular about your stream? So, for example, one particular VN or VRF or whatever you could actually send different VRFs on different streams, and I'm thinking there of like a data center interconnect scenario where you might want to be able to manage what VRFs are, or maybe even VNs are being communicated across a DCI connection.
Mm-hmm. So the protocol would let us be able to do that sort of thing if we're willing to change BGP up a little bit.
Mm-hmm.
So if we're willing to take, using your example, or layer 3 VPNs, and have lots of different streams that are dedicated towards subsets of specific VPNs. You could technically do that. Same thing we were just talking about, and the challenges become, how do you change the protocol up so that it deals with what does it mean for a given address family to have an issue or get a refresh or other things like that. And there have been proposals in IETF before about doing things that actually are per VPN. There's an active draft that is working close to a last call in IDR right now about a VPN-based ORF for refreshing things. Use case coming from a lot of our Chinese colleagues for refreshing things in cases of prefix overruns, because a challenge you have, especially with the multi-provider VPN network, is what happens when somebody opens up the sewage line and you basically floods out everything, and you have too much going on. You have to throw the stuff away. Question is, how do you get it back? And it's an example of being able to ask granular refresh type things is a useful thing. Your point sort of, could we take those things and start splitting them up on the different streams? And we haven't spent a lot of time talking about that level of granularity beyond the protocol quirks that have to be addressed.
Mhm.
But the headache would run into, I'm pretty sure, is that after a certain number of streams, you're probably putting too much burden on, let's ignore the sending side, but just think about the receiver. I've got 100 different streams that I'm trying to process. These things are probably funneling down into a narrow set of processing capabilities within the receiver. Maybe you have, let's pick a sort of theoretical nice implementation where you actually have each address family managed by a thread.
Yeah.
That the routing table is all local to that, so you don't have to worry about any of your table contention. That probably means that for that circumstance, you could probably have a thread per stream, for address family. If you want to get more, granular, well, where are you getting your benefits on the receiver? Do you have a thread basically per VPN? Does that make sense in your implementation? And end of the day, all these sorts of things eventually come down to resources that share fate with each other. So if you have all your VPN stuff shares fate, do you get a lot of extra benefit by sharding it out across multiple connections? Well, maybe yes, maybe no. It depends on your implementation. But I think a lot of it's going to come down to other shared resources that they depend on, and eventually, even if you have a lot of things that are eating the streams as fast as they can, the QUIC protocol token manager is eventually, I think, going to give you some pushback. You're just simply not going to be able to keep individual streams consistently busy between two boxes. So you stop losing the benefit of the streams as a multiplexing mechanism, and you start running into staggered flow control. And I'm sure there's guys that actually specialize in QUIC that have thought this stuff through, and that's a good conversation to have.
Yeah. For
So
that level of granularity, technically you can do, right? But the thing is, for protocol design, you have to consider the more flexibility you add, it may become more complicated, right? Especially for implementation. You have to think of bugs.
I would point to HTTP 1 when we were opening TCP session per object request, right? Didn't really work. So where I wanted to go with Jeff said is that while BGP is reachability protocol, we're kind of handling more and more stuff that has nothing to do with reachability, right? It's pure metadata, could be anything really. Right. So kind of now looking at Rift, we managed to build in-band metadata distribution channel that doesn't really bug the core of the protocol. It doesn't exist in BGP today. So why BGP in data center is so scalable? Because of very nice properties of BGP, you merge everything when you have merging kind of node that has many routes from downstream, like typical spine or super spine. Now, if you want to be more granular, imagine weighted CMP. So suddenly, I cannot have one route. I actually need to have either more routes and do something. So actually, there is kind of disaggregation happening as I want more granularity or more metadata attached. If we could somehow leverage this additional streams to make sure that metadata doesn't interact in negative ways with reachability, which is much more important, maybe there's huge win, especially at large scale.
Yeah, it's sort of hitting, that set of points two different ways. So the BGP monitoring protocol, BMP, has gotten a huge amount of work in IETF, with putting in annotations inside of the BGP state that's getting passed around. So people will get things like, why did my route get rejected via policy? Is this thing, got specific attributes tied to it? And there's an awful lot of things that they're playing with right now. And as you're saying, this stuff is just basically metadata that's on a individual route basis, and they're providing a mechanism BMP to pass the stuff around. where you start running the interesting headaches about, sure, you could start doing non-BGP things over this BGP over QUIC, connection. At some point, there's a choice we have to make. We either say we're going to keep this basically simple BGP, which is what we've chosen to do to this point, or do we make a choice that we're going to open it up and make it a little bit more TLV extensible and allow for other stuff to go on there. And the choices we get to have there is basically going to be complexity. Are we willing to throw this metadata as another stream on the session? Are we going to let that metadata, this is sort of a good comparison through BMP, providers that use BMP for their traffic engineering, they want it to go as fast and be exactly the same as their BGP. It's just as important. But if it's just annotation data, you're fighting for real data mixed in with actual metadata. The flow control, the prioritization, those stories keep on piling up and getting more interesting. And it's back to the same conversation. What does the token buckets for us do for our throughput? Do we start having issues with metadata competing with actual routing data that we want to converge things fast?
So I think the kind of stream level abstraction gives you kind of clean way to do this. So you don't need to extract this data. And practically today you are limited by how fast you can do best pass, because otherwise there's no update. If you can let it go through just keeping them in direction, so you can actually associate route received to metadata received, maybe you can completely decouple it and make GP much more sensitive to stuff that's not related directly to reachability.
Right. Where we have an interesting second inflection point is we don't have to layer it all into a single session as long as we have good keys to tie the stuff together. And that's mostly what people do today. And it sort of hits one of the interesting points about QUIC as a protocol. One of the properties I don't know if you talked about on your last show was that some of the people that design QUIC talk about it mostly as a way to hide traffic, from people that really shouldn't be looking under the covers. You can't really see terribly much what's inside of your QUIC connection. And that's a good property for some people that want to just get their traffic through as fast as possible and not let it be meddled with by traffic classifiers, those sorts of things. But everybody that's building some flavor of real router, or somebody that's running maybe more than one transport for whether it's your IGP, whether it's BGP, whether it's things like your NetFlow, your CLI, whatever, these things are all eventually competing. They get to whatever you want to call it, your product's central CPU for the router. The host path is what we call it in Juniper. So when you're trying to fight to get to this restricted resource, and just as importantly, you're trying to keep the outside world from doing bad things to that important bit of CPU, that means that you end up having to do some interesting classifiers there. And with QUIC sort of hiding things from us, that means that once we start looking at multiple QUIC sessions or multiple other transports competing versus this stuff, do we run everything inside of a single QUIC connection? Tunnel everything over the same HTTP session that some people see for their home VPNs, or you split it across a lot of different things? How do you eventually choose what gets prioritized and passed along? And that becomes an interesting conversation.
I think we mentioned it when we were chatting before the show started, and I can't remember if I mentioned it after the show started or not. But I was sort of saying, well, things that QUIC advantages that QUIC was actually designed to address. I think things like head of line blocking and latency and congestion and that sort of thing, all coming from Google, obviously for web traffic. But what just occurred to me as we were talking, we've in previous shows we had Marc Blanchet on, who is doing a lot of work specifically around deep space communication. So you start talking to satellites or settlements or whatever, on Mars or around Mars. TCP is impractical because of the time limits and such, and so there's a lot of interest in QUIC for that. And then we had Tony Lee on talking about some of his ideas around satellite topologies and specifics of routing among satellite topologies, and so just as we're talking, it occurred to me that BGP has a role in those kinds of things too. You'll eventually be wanting to exchange reachability information with a settlement on Mars or a satellite around Mars, and or just simple something much more close to present topologies just in a satellite constellation around the Earth that are going to be using BGP to exchange reachability, and so some of those characteristics of QUIC even apply there, I think.
And Mark is using QUIC extensively.
I'm sorry?
Mark is using QUIC extensively in his work.
Yep.
Yeah.
Right. So, it all depends. It depends a lot in those scenarios on the time frames, right? That's why most of the TN networks use the bundle protocol as the transport, because, you never know when a satellite or a moon or a planet is going to get in the way of you communicating with not just Mars, but, Saturn or who knows where. And so I believe that, some of the time scales are going to be too long for some of these protocols. Now we're talking about what seems to be what everyone wants to talk about, which is low orbit satellites. Yeah, sure, that's a different story. And we're talking in some cases a lot of overlap depending on the constellation you're talking to, or phasing of 5 minutes maybe, that maybe you lose coverage. But the more and more you see constellations like Starlink, for example, out there, the less you see those interruptions. So your communication, which might be end to end, will never be really interrupted. Now, communication with the satellite, that's a different story. But communication through the satellite network should work almost as it does today, right? With the same resetting of links in the middle of the network that go up and down, and packets get rerouted, just like they do today. It's just a different scale or speed of how much a network changes, right?
Yeah.
Probably there's some latency boundaries. So below you could do things that you did before. There is 160 pages document describing how to use BGP in aerial space in routing working group, actually implemented by Boeing partially. So here you're doing the same, maybe a bit different, but as you go towards interplanetary networking, suddenly all bets are off, right? You're in minutes now.
Right, and that's really the problem. I mean, today we have Starlink, and I can watch Netflix and normal stuff using my normal computer that doesn't necessarily have anything special on it or modified, right? It uses the same protocols that wired internet uses, and it works. So yes, as we look, way beyond there, and start looking at, as you said, Mars or beyond that, that's where we really have to worry about connectivity.
Probably should touch upon user space implementation of QUIC.
Yeah, that's actually worth talking about, because it actually overlaps with exactly what we're talking about in terms of latencies and such. Pretty much everybody who spends any time being a BGP expert eventually becomes some flavor of low-level TCP expert, at least early ends of it, because quirks in TCP are problematic. One of the talks that's coming up at the upcoming NANOG is about what happens with 1% packet loss. I'm sure they're not going to specifically talk about BGP, but having been there, the amount of packets lost for normal TCP to make your session get all sluggish isn't all that much. So the timers start getting very perverse when you're talking to something far away. So even if we're talking about, not even to Mars, but talking from my home in Michigan to Australia, if we happen to have a little bit of hiccup in terms of how the packets are going through, if we got too much jitter, we're actually going to see that the TCP throughput, even for something as boring as a small amount of data BGP has, the windows get full, you start getting blocking, and things just simply don't move smoothly. And we spent an awful lot of our time in BGP land, in our various stacks trying to optimize our TCP to do better. Some stacks do better than others. Some of it depends on what operating system you're on top of. We don't have quite the same experience with QUIC today. And one of the places, as Jeff mentioned, that's going to be sort of interesting is a lot of these timers are talked about in the specifications, but they're implemented depending on what you're doing in either user land, or you might actually have a version that's been put into your kernel. And one of the reasons why BGP security extensions for like AO took so long is BGP developers are really just application developers. It's just a socket. We want to call open, we want to send stuff, and we want it to just work. But if you're having to take that burden and throw it into your user land stack, which if you're doing old school RTOS for even TCP, same type of headache, it's now up to what you're doing in your user land to actually manage your throughput, which can be next door, halfway across the planet, or over to Mars.
Mm-hmm. Yeah, and it's out of all of that, and I'm sure anybody listening to this show probably knows that, but when we talk about TCP, going just to what you said, Jeff, when we talk about TCP, there's a lot of different TCP implementations out there. It's sometimes if you're getting deeper into things, it's important to talk about, well, what implementation are you actually talking about? Some are better than others.
Yep. Sometimes it's a matter of timers. Sometimes it's a matter of buffers that are chosen.
Yeah.
And one of the things that's going to be very challenging at the user land for QUIC is, just in terms of complexity for what BGP over QUIC is going to mean for us. We're no longer managing a single socket anymore that just simply push on one side, pull on the other. If we're very lucky, using APIs, because one of our headaches is QUIC does not specify a generic POSIX style API. It talks about what the protocol does, and there's a lot of different implementations these days. Yeah. And that means that we're going to be running into all sorts of interesting interoperability conversations over the long term. But we'll work on the protocol piece, and we'll figure out the implications about what the stack in question gives us when we get to it.
Yeah, so if you look at the interactions between BGP and TCP today, right? So because there are so many different TCP implementations, whether certain event can be sent to BGP is really up to the implementation. So we are gonna face the same issue with QUIC. And we have no control, we cannot control like all the implementations and exactly the same kind of events to BGP. So we'll face the same problem. Welcome to the Wonderland.
Well, this is why we do this work in ATF, right?
Yeah.
Yes.
The main job of TF is provide interoperability. And
so we can make certain
read it and understand it the same way, which is not for
we can make a requirement of certain important events, like a mandatory events. That's pretty much it, right? Yeah.
Yep.
You still cannot guarantee all the implementation will follow the rule.
Yeah.
One thing to sort of keep in mind, there's a lot of cool things about QUIC that I think we're going to try to take advantage of over the long term. We talked about the security aspects and certificates. We talked about session resumption. So we might be able to leverage some of these things in a way that's useful to BGP. That's something that's not there. But most of what we're really specifying, once you sort of subtract, a bit of verbiage about there being a QUIC stream on one side or another, we're really specifying how BGP behaves when it has a layer 5, and we actually get more than one stream to do things. And some of us spent a little bit of time overlapping this bit of work many years ago, back when SCTP was a new thing. And as a protocol, it's mostly successful in the VoIP space, but it did have some of the same properties at the very high level that QUIC gives us today. But the APIs were just simply not really suitable for trying this sort of effort. But if tomorrow somebody introduces a new thing that does a layer 5 that we like, just like BGP is quite happy running over anything that's a reliable single stream today, whether it's a IPsec tunnel, Unix domain socket, whatever, hopefully if we've done our homework right, we'll be able to have what we're calling BGP over QUIC, which may get a rename as we continue working through things. It's basically BGP over streams. How does it behave? And if we can get it working right, swap out the transport for something else. And that goes back to your question about what do you do about talking halfway across the solar system? Well, if QUIC can't do it, but the protocol is good enough, well, we know what the protocol looks like. We just have to swap the transport.
There's comment from Mazen saying that all CD implementations are the same, the only different congestion protocol. So RINA versus QUIC versus BBR and so forth.
Yeah. So getting down to our last 5 minutes or so of the show, I'm curious, how close are we to running code, or are we still just ironing out the protocol specifications at this point? When do people are going to want to know when will we see vendors actually deploying BGP over QUIC? A lot of silence.
Anyone want to? I'm going to say, vendors deploying them over the real deployments is going to take a while.
Yeah.
We need to, and for this we need the help of not just us, but the help of everyone to start playing with our specification to make sure that it actually says what we think it says, and start doing interpretability testing. I think because of the big change of the not just the transport, but how BGP works, and Yingson and Jeff mentioned earlier the work with the state machine, and how it's very different from BGP over TCP. Then we need a long testing phase. I would hope that soon, right, for some value of soon, we'll see test implementations at least.
Yeah.
And then hopefully, we can start trying to interoperate them and see what holes we need to fix and where clarity is needed the most.
Yeah, and to add to that, there's quite some work going in academia on this topic. It's an exciting work, and I know Olivier Bonaventura has been working on it for a couple of years. They've been preparing some papers to publish. I'm not sure they have already, but we should be seeing this year significant input from academia on this exactly topic.
Yeah, because we now have separate control channel and function channels, so we actually changed the original BGP finance state machine quite a lot. So we are in the stage of trying to iron out all the details, make sure we cover everything, and when you read it, you know what we are talking about, right? At least we try to make sure that you, and at least your understanding will meet our what we really meant to say, and make sure we cover all those details, and then we'll looking into testing some prototypes. Yeah,
and that's very much where I'm at right now. The state machine stuff is the tricky piece. I think an interesting conversation when we're done is, have we changed things enough that it stops being BGP4? Maybe we start talking about being BGP next. That was one of our conversations last time I was on the show. And once we sort of know how it's supposed to behave, it's like I said, for the most part, anybody that does BGP sort of has a feel for how this is going to have to work. But ironing out those details in a formal state machine when we did 4271 was how we realized that we had sort of sharp edges where the spec talked about something and different vendors came to different answers. So we're spending a little bit more time up front on that exercise. But at some point, I hope to just simply start a prototype and see if what we actually are talking about actually meets code and actually does the right thing.
But my hope here, again, to what Jeff said, my feeling is going to be BGP next. There are too many changes to BGP4, right? So my hope is to take things that we thought much later than before spec was published, that they are a great idea. Let's make them mandatory. Let's make end of RIP mandatory. Let's make things that we actually developed in the last 20 years since 4271 was published. Let's make them part of the core protocol, because we know they make protocol better. Why don't make them mandatory? So again, I think it's very important part that's kind of decoupled from QUIC, but more coupled to evolution of BGP as a protocol that kind of address more recent requirements.
It makes huge sense. Well, it looks like we just hit the top of the hour. Any last comments before we wrap everything up?
Read our draft, send comments.
Yeah.
Yeah,
We need a lot of help, and this is a joint effort from everyone.
Yeah.
absolutely.
Please review and send us your comments.
And
The
current draft is 4, I think.
Right.
4, yes.
That was
And if you happen to be budget holder and you're interested, use it.
Yeah, we actually have a GitHub repository. That's where we have the latest version.
okay. All right. Well, Yingjin, Alvaro, Jeff, thank you so much for joining the show today. This was I learned a lot myself. I found this a fascinating conversation, and would love to have all of you back sometime to maybe discuss the next steps. I love the idea of BGP next, and see how the ideas start swirling there. Jeff T, any last words from you?
Yeah, I just thought we should break bottle of champagne on the first router that ships with BGP over QUIC. When new ship goes in, you kind of break champagne. We do the same.
Yeah, there you
Sounds
go.
like a plan. Thanks for having us.
Thanks.
Happy to be
Thanks for
here.
being here. And everybody, thanks for joining us. I hope you got as much out of the show as I did, and we'll see you on our next Between Two Nerds.
Bye.
Bye, everyone.
Bye.